percentage form. Right. Okay? Now, so this is what we have done the last time. This is called a pie chart. Now, I still hear noise a bit. Alright, now, next one I want to tell you is actually a line graph. Okay, I'm just going to teach you what's a line graph first before I go on to the textbook. Would that be okay? A line graph shows upward or downward trend. Upward or downward trend. Understand? Now, let me just give you an example. For example, this is number of cars, and this is the month representation. 0, 50, 100, 150, 200. Okay? Now, this is January, February, March, April. Now, what do we mean by that? And all of you look at the board. I don't wish to scold people today. So, all of you look at the board. Very fast one. Does she anything? No. Okay. Now, for example, in January, this particular shop sold 50 cars. Okay. In February, this shop sells 100 cars. Okay. In March, they only sell 25. Then in April, maybe they sell 75. So all these points are joined by line segments. Understand? What does it show? All of you look up. It shows that from January to February there's an increase in the number. This one means what? Decrease, then a increase again. Now, the intermediate values. What about intermediate? For example, if it's halfway, it doesn't mean that on the 15th of January, they will sell 75. No. You understand? So, the intermediate values have no meaning in this particular example. Is that clear? Is that clear? The intermediate values have no meaning because we cannot say it's the 1st of January or 15th of January and so on. It's just showing upward and a downward trend. Is that clear? Okay, now, then I want you to look at this one. Now, in some examples, you have this zigzag sign. What does this zigzag sign mean? It means that for this particular set, it doesn't follow the scale. Okay? For example, I have 35 degrees Celsius, 36, 37, 38, 39, 40. This is a body temperature. Other than that, maybe die already. Okay, so just until like that, that's it. Okay? Now, for example, this patient is having fever. Understand? So, at 9 o'clock, it may be 38 degrees Celsius. Then, at 9:30, it could be 39. Then, at 10 o'clock, maybe it came down to 38.5. Can you see it? Like that, so on and so forth. This is also a line graph. And this one means what? It does not what? Follow the scale. Okay, it will start from 35. You cannot have someone having 0 degrees Celsius. The person die already. Understand what I'm talking about? Huh? Okay, now, for this and this, what's the difference? Now, do you agree that this one will be 9:15? Yes. Will this have meaning? Yes. Because do you agree that temperature it will increase gradually and decrease gradually? It won't suddenly from 30 pounds straight away 39, right? Correct. So this one particularly, the intermediate values can have meaning. Understand? But this one, the intermediate value has got no meaning. Doesn't exist. Okay, now, what if I started this line graph, the same one, right? From 0. All of you look at that. Now, first one is 38, right? So maybe somewhere here, right? At 9:30, what's the temperature? 39. So it's somewhere here, right? What is at 10 o'clock? 37.5. So it's somewhere here. Now, do you agree that, okay, let me just maybe go 10:30, maybe it's at 40 or this person, you already have high fever. So at 10 o'clock, at 40, already high fever. Now, do you see that in this one, the fluctuation is more pronounced? That means it's more evident, more obvious. But this one, it might look like it's just here only. Can you tell me why? How come this one looks more gradual, but this one looks like, wow, fluctuate a lot? Why? One starts at 0 and one starts at 35, right? Now, can you see if the person fall down to normal 37, right? You'll be here, right? Okay? This one, if the person fall down to normal 37, can you see it's just like a small increase or decrease? Can you see it? That means this one, I'm using a larger scale, you can see. Then, the fluctuation looks more pronounced. Okay, or more evident. But if you use from 0, then you will roughly be about a straight line, because you'll be there only now. You understand? So, can someone tell me what's the advantages? What is one advantage of doing this? This one. You can see more accurately, right? But there may be a misconception here that it fluctuates a lot. Agree? Now, what's the advantage of this one? Is there any advantage of this one? Actually, it only fluctuates a little. What's the disadvantage? It's not amplified, that means it's not enlarged. So it's not difficult to read. Are you clear with what I'm saying? Okay, so the number of cars example, the intermediate value has got no meaning. But for a temperature case, the intermediate value may have meaning. Do you understand? So it depends on the situation itself. Everybody clear with what I'm saying here? Okay, now. Alright, good. Then, one last thing. What does this zigzag sign mean? Not drawn to scale. I just start from 35. Is that clear? All this we ignore. Clear? Okay, good. Now, we turn to the next book. Okay, all of you turn to the textbook, page 200 something, okay? All of you turn to page 209. 209. Remember the day I showed you this one? Correct. Okay, then I also show you this one, the advantages and disadvantages. Okay? Agree? Okay? Now, then, just go through the plan. Let us go through example 1. This is example 1. Okay, I'm going to go through the example. I know what you're doing. What are you clapping for? You love the pie chart? Yeah, pie chart like that. Can you pay attention? Okay? Because nobody is talking to you. That means there's another girl standing down there. Because the other day you come back and ask you, you say you are not talking to anyone. Page, someone is asking me. 212. Page 212. Thank you. Now next, express the amount of fat as a percentage of the whole of all the components given. Now look at fat here. How many degrees? 2x. Okay. Fat corresponds to 2x degrees, right? Which will be 2 times 18, right? This will be 36 degrees, right? Okay. So the same percentage will be 36 degrees over what? 360, because all components times 100%. So this one will just give you a 10%. Are we all clear? Okay, now, what if I want the amount of fat as a percentage of carbohydrates? Then what do I do? 36 over what? Carbohydrates, 144. So you must read the question properly. Do you understand? Okay. Last question. Given that the food product contains 120 grams of carbohydrate, calculate the mass of the food product. Okay? Can I clean off this one? Yes. Now, how many degrees is carbo? Yes, 144 degrees correspond to 120 grams. The whole food product is how many degrees? 360. Very good. Now, can you see I use the usual? Can you see that? Okay, so I will get the whole food product as what? 300 grams. Is that clear? Is that clear? So what I'm saying here? Okay. Now I want to ask, what if I want you to find the mass of protein? 144 degrees correspond to 120. 9 times x, right? So I'll take 9 times 18, right? How many degrees, then you see how much it corresponds to. Is that clear? So, pie chart is very simple. Everybody will know how to do it. Is there another one standing in the back there? I find it's very dangerous sitting at this side of the room because you can't turn to the back. You're laughing, Okay. So, this is your example 1. Are you okay? Yes, okay. Now, next, can you look at page 213? They give you a line graph which I already explained just now. Temperature. Okay. This one you're going to read through it yourself. Alright? But I want you to pay attention to page 215. Oh, look at page 215. Now, what are the advantages of line graph? Used to observe the rising or falling trend of a set of numerical data over a period of time. Must not read in between the plotted points, unlike graphs of linear functions. Now, we have to be careful and observe if the vertical axis starts from 0 or otherwise, right? Okay? If the vertical axis does not start from 0, the data may be distorted and misinterpreted, just like the bar graphs. However, for data with small fluctuations, the vertical axis starting at 0 will prevent the observation of these minor changes. Let's take a look at this. However, for data with small fluctuation, the vertical axis starting at 0 will prevent the observation of these minor changes. Remember I told you it looks like a straight line? Correct. Okay, let's get going again. With small fluctuations, like 37 to 7.5. The vertical axis starting at 0 will prevent observations of these minor changes. It will not be that pronounced. Okay? Now then, I want to ask you one simple question. Okay? For example, let's say favorite colors. Green colors, red, black, white, blue. Okay. Supposing this one got 10, this one got 12, this one got 9, this one got 8, this one got 14. Now, graph? Is there any meaning if I represent it by a line graph? Can you see that if I represent it by a line graph? Number of students, then the color. Can, but there's no meaning. Green, red. So what if there's a decrease? There's no trend. You understand what I'm talking about? So is it appropriate to represent it by a line graph? No. It's not appropriate. So you must know. Understand? Now, if I want to read the number easily, which representation should I use? Bar graph, right? Correct. If I want to see the proportion clearly, like which one has got the most people, which one? Pie chart. If I want to see whether there's an increase or decrease, I will use the line graph. Understand? But there must be a trend. It cannot be like that one. This one you use line graph, but don't use one. It's just a waste of time. Do you understand what I'm talking about? Okay? Alright, good. So that is what I want to say. Now, let us look at example 2 now. Look at example 2, page 216. This one. Okay. If I catch you not paying attention, right? You're looking at your Chromebook for nothing, right? I will take the Chromebook. Close your Chromebook. Don't let me see it open. Okay. Now, the line graph shows the rubber consumption of the automobile industry in a country from January to May of a particular year. In which month was the rubber consumption the lowest? Look at the line graph. Which month is it the lowest? May. May. Are we okay with May? Yes. Okay. Now, next, part 2. Using data from the graph, construct a table showing the rubber consumption over the 5 months. Now, I need to warn you. What's this? Tons. 1 ton is actually 1,000 kilograms. Understand? Okay? We never have a tire, so you want to tell me a story? No. So the question says, show a table. Now, can you just speak for me? January, what's the number? 170,000 tons, right? Yes. Do you all agree? So on and so forth. Okay? So, when we write the table, it becomes like that, right? Very easy, right? We just construct the table like that. Can see it? Okay? According to the line graph, we just transfer it to the table. Okay? Now, last part. Last part, huh? Part C or part 3. Calculate the percentage increase in the rubber consumption from February to March. Okay. February to March. Can you tell me February, what is the answer here? Okay, mine is a bit out. Let me just readjust it. Okay. February, what is it? 1,550,000, right? What about March? 200,000, right? Alright. Now, may I know what is the increase? 200,000 minus? Okay, so how much is this? How much is this? Okay? 45,000. Okay? What did they ask for? Can you tell me? Percentage what? Increase. Okay. So, percentage increase will be this one over. It must be over the original, right? So, which one? 155,000 times 100%. Okay? If you key in your calculator, can you tell me what the calculator gives you? 0%. Are we all clear? Are we all clear? Yes, huh? Okay, good. Now, can you all look at practice now 2 over the next page? And do the question for me now. In the textbook itself. Do the question for me now in the textbook itself. All of you. So that you can finish this by the next lesson for me. Can you do just practice now 2? And you read page 218 to 223 yourself. I will not go through these few pages because you can read and understand it yourself. Is that clear to everyone?